All right, so in order to capture lift data and get actual number values for each of these different airfoils, I've come up with a fairly simple mechanism. So I've got the whole wing and stand system on a gram scale, as you can see here. This weighs about 203.8 grams. And when I go to turn on the fan, which you'll see in just a second, you'll see the number go down, which means the wing is generating some lift and pulling up on the whole assembly here and reducing the amount of force on the scale. So this is a way that I can quantify how much lift it is generating at each angle of attack. So I'll show you that right now. Alright, so this is the fourth airfoil iteration. This is the USA 35 Bravo with the leading edge cuff and trailing edge flap. So I'm going to go ahead and run it through the various angles here. And also on the screen you'll see the gram scale and what it is reading. You'll see the number get lighter as it generates lift, and then suddenly when it increases, that's when the airfoil will stall. Okay, so here is 0 degrees. And 5 degrees. Now up to 10 degrees. And 15 degrees. 16 degrees. 17 degrees. 18. 19. And 20. So now that you've seen the fourth airfoil going through its lift test, now here's just a supplemental video to show you how the smoke is interacting with the wing. So you can see here when it starts to stall about 16 to 17 degrees, all that smoke buffeting off. So after testing all four airfoils, I've compiled all the data into their own graphs and plotted the angle of attack and coefficient of lift. So I changed that grams of lift into coefficient of lift. You can see this one critical angle of attack is 17 degrees, lift coefficient 0.114. Next is the trailing edge flap. You can see the critical angle of attack here has gone down to about 15 degrees, and the coefficient of lift has gone way up to 0.141. And you can see what it looked like with the smoke there at various angles of attack. And next we have the leading edge cuff with a really high critical angle of attack of 20 degrees, but the lift coefficient just about 0.116. And there's what it looked like. And then finally the combination of both critical angle of attack right in the middle at 16 and a pretty high lift coefficient. Well, this concludes the 4-part series of my senior project documentation. Thank you so much for watching all the way to this point. I've learned so much from this project, from engineering small devices to understanding more about lift and stall theory, Reynolds number physics, the differences between angle of attack and pitch angle, and so much more. And a big thanks to all the mentors and advisors and teachers that have helped me out on this great project. Thanks again.